Happy to be here. I've been working in the technology development region space for about 10 years, mostly in infrastructure, so power and communications. And this is our kind of latest project, which is on how to do community cellular networks. Now, I think it's pretty clear that cellular has been pretty successful, most successful technology ever. I think that's fair to say that more people have cell phones than socks, toothpaste, lots of things you'd expect to be ubiquitous that are not. And also worth pointing out that it's a necessity in the sense of the hierarchy of needs, in that people actually do pay for cellular over other things, which is surprising. 7% of income in rural Bangladesh is spent on mobile, and it's by choice, right? There's no coercion there. And part of the reason that it's popular in these areas is because the things it enables. In the case of Bangladesh, it was largely for enabling remittances. How do you arrange incoming cash from relatives? Same for the Philippines. The Philippines has much more money, I think $4 billion a year in incoming remittance compared to what it gets in terms of all kinds of other financial aid. In many cases, the phones increase income in various ways. The classic example is better information about prices, so that you actually get more for your crops, or you harvest them at the right time, because if the crops are going to spoil, you want to pick the time carefully. Fishing actually has been shown to have benefits from connectivity for fishermen. And the most obvious one, if you go to at least the urban areas, is probably taxi drivers, who now have a way to get customers other than literally bumping into them, right? And so there's a lot of things going on here that indicate that people act and want this in a real way. But the issue is really that there's this last billion users that's actually not covered. And it's unlikely to get covered on the current mechanisms. In particular, they have limited coverage because they live in rural areas. And by the way, this includes the United States. This is not limited to the Congo, right? This is all rural areas. And really the goal is to connect these people, or at least give them the option, right? They may choose not to be connected, but I want them to have the option. Now, why no coverage? The first reason, and really the root reason, it's not economically viable. If it was economically viable, they're paying customers there, there would be service there, right? And it's really because of population density. So when I say rural, what I really mean is low population density. And in particular, the costs are higher to serve these areas because you don't have a lot of existing infrastructure, and the number of users is lower, right? And that's a bad combination. So I would say carriers never choose to cover these areas. They might have to as part of a universal service or a public good, but they never choose to, right? When you buy a spectrum license, you're not buying it to cover these areas. But you cannot cover these areas unless you have a license, right? We'll come back to that. And this is really the essence of it. The carrier structure is an economic term, is a structural problem. And really, not only do the carriers not cover these areas, but if you wanted to help your community, you are not allowed to cover these areas, right? So it's worse than that they won't cover it, it's that they prevent anyone else from covering it also, at least as currently structured. So in particular, the spectrum is owned but not used, and I'll come back to that also. So our approach is going to have a few different pieces. We have to change the economics. So first thing we need to do is greatly reduce the cost. And that's both the capital, how much do you have to put in to set up the network, and also what does it cost to operate the network monthly. Both of those have to be managed. If you want, you can translate capital to higher OpEx, but in practice, the upfront capital it's a big barrier. Next thing we need to do is really enable local ownership and operation, right? Make it easy enough that a community could set up their own network, the same way you set up your own Wi-Fi hotspot. It ought to be that easy, right? And because Wi-Fi hotspots are not that different, it seems pretty plausible. And finally, it's pretty useful to enable localization. One of the side effects of the carrier structure is that all decisions are national decisions, which means that what the pricing is, what services are offered, what numbers are free, those are all made on a national scale, and you might make different decisions for your community. Right? So I want to enable that kind of localization. So we've built a community cellular network. I'll get into the details in a minute, but it's in this highlands of Papua, Indonesia, discovered, by Westerners at least, relatively recently, right? Really incredibly recently, if you think about it. This village has about 1,500 people, 10,000 in the district, 9 people per square kilometer, right? That's a very low number. Then New York City's 10,000, San Francisco's about 6,600, right? And so it's not that many people, and that's really why there's no coverage here. So what we deploy is a base station, which is the thing in the bottom left corner. It's basically a mini server that's running a software radio, a power amp, and not much else. Right, so that goes in that box on the pole. The pole is then put on the tree on the right because we don't want to pay for a tower. It's powered in this particular deployment by sharing power with a school that's micro hydro, and it's also sharing a VSAT backhaul link with the school. I'll come back to both of those points, why those are important. It uses existing handsets. In fact, most people have existing handsets, which is interesting. They have them because they travel to the big cities and use them there. So even though they didn't have coverage, they have handsets. And I see this worldwide. For example, in India, there's a large use of handsets as radios. So you use it as a radio when you have no coverage, and use it as a handset when you're in the major city. Got to make our own SIM cards. That was kind of fun. That's the white SIM card down in the corner. So to be on this network, you have to have one of our SIM cards. Although in theory, we could open it up in general, but we actually want to track the users and we want them to opt in. So there's ethical reasons to use our own SIM cards also. Now, here's the pricing. These prices I actually think are high, but they were set by the community. Technically, they were set by the local company that the community formed, which kind of mostly represents the community, but there's always some questions about that. Certainly they're from the community. Now there's voice calls that are local. There's actually no global voice calls. I'll get to that in a second. The main thing that's used actually is SMS. And so the local ones are 2 cents, the global ones are 9 cents. I'll show you usage in a minute. And although we could offer data services, we are not currently. Partially because the demand is for voice and SMS, and partially because it's more complicated technically and we're trying to simplify it. But I do think particularly local data access is very easy to do. Global internet access needs a more significant backhaul, and that's going to be expensive, so that's a longer conversation. At the moment, because we're sharing the VSAT with the school, they've decided they don't want to give us enough bandwidth to do global calls, and the demand hasn't been that high, although I think we will add global calls at some point. There is a similar network we work with in Oaxaca, Mexico, and they actually do use global calls, and they are actually using US numbers because they're basically, this kind of system, the calls are VoIP calls, so you can have whatever number you want. Our numbers, it turns out, are Swedish numbers, which is not a great choice, except that we couldn't get Indonesian numbers, and the Swedish numbers were cheapest, and once you're not getting Indonesian numbers, there's no real reason to pick one over the other. So the voice calls can work globally, but they haven't been worth the bandwidth so far. We'll see if that changes. Another kind of thing that's local is a few of the services. This is all prepaid in the usual sense, but we don't have scratch-off cards. So the way it works is dealers buy credits prepaid, and then they can transfer credits to you over SMS, and that's actually how you get credits. So there's essentially a little dealer network that sells credits. And it turns out you can also, you yourself transfer credits to your friend, right? So in fact, you can do micropayments that way. We have seen some traction around that. We've also, at their request, added delivery receipts because they really were skeptical that people were getting their messages. So now that's something that actually could turn on anyway on phones, but they didn't know that, so we just kind of turned it on by default, and that seemed to be popular. And that's really, I think, because the communities don't have that much experience using phones compared to, say, this audience. And so some things that they might feel differently about this, I would say, in 5 years. We'll see. I'll just give you a few quotes to get the sense of it. So kids, many of them are taking studies in Jakarta, Sentani, in Manado, in Jogja. So parents are happy because right away they SMS. Right? What they mean is they can be in touch with their students that are studying in other cities, because there aren't any really, there's barely a high school here, right? There's not really a high school, and there's certainly no other educational opportunities above that. So a lot of kids are there. Conversely, the teachers and doctors that come into this village use it to communicate with the village that they live in, right? So that's a really important part of this kind of usage. And this one's also a classic one. Wamin is the nearest big city, which is 4 hours away. I don't have to go to Wamin anymore to send them SMS or to phone. I can relax here, sitting in the forest, roasting cassavas. Right? So people like living in the village they're living in. So I think people, one thing I've seen in these developing regions is the rural people are quite happy, and it's actually a higher quality of life than living in an urban slum by a lot. It's just that historically there's more hope in the urban slum for a change of life. Right? It's very hard to change your life if you stay in the rural village, and I think connectivity is one avenue that will improve that. So this is, I don't know if you can read the small writing, but I will explain it a little bit. This is basically from February to September of this year, which installed it in February. About, of the 1,000 or 1,500 people in the village, which counts all ages, about 225 are using the system based on the SIM cards. And really the things that are growing and have lots of use are the outgoing SMS. So the biggest single use is actually the SMS outside the village. And that can be to the students in other villages. It also, of course, can be global, because there's no price difference for global versus next village over. Incoming SMS from the outside is the second most used thing. So really there's a lot of external communication going on here, and that seems to be driving actual, both the user stories and the usage. And then all the other things are relatively used, but relatively flat: the local calls, local SMS, payment transfers, things like that. But good usage and pretty good growth. So I'll talk about some of the shifts here, because they're pretty substantial. So we need to change the economics. So this is how we do that. On the left is traditional costs of a rural base station. And I've seen actually much higher numbers. Like, I know a rural base station in Ghana is about 500K, right? Because you need a big tower, you need big diesel generators, you need the road to bring the diesel to the diesel generators. So you have to add all those things. It's the fully burdened cost that kills you. In our model, the base station, although we paid probably 10K for it, it's more like a 2K bomb, and it would be something less than 5K in any reasonable quantity. It's basically, it's a server and a power amplifier in a box, software radio. You saw we're using a tree instead of a tower. I estimated $500 for the poles and the labor and all that for the tree. I don't really know what it is, that's probably high. We usually use Wi-Fi for backhaul. I said we're sharing VSAT for this particular Indonesian thing, but they're adding 2 more base stations in the same area, and those will be connected by long distance Wi-Fi back to the same VSAT line. Right, so their marginal cost for backhaul is quite low. Power, we're about 70 watts, so you can do that with solar, micro hydro quite easily. All that power is pretty much the power amp. And then the reason, by the way, our power number is so much less is that we are not trying to have 1,000 concurrent calls, which is what a traditional base station does. We're trying to have 7 concurrent calls, 10, 14 concurrent calls. Right? That's actually enough for a village of this size. So it's not that we have some magic solution. We're actually just building a much smaller, less capable base station at much less cost and much less power. And finally, the road, because as you saw, this is a very small thing, you can kind of put it anywhere, right? You don't need to, you can backpack it in if you had to, right? So we need some height to get good coverage of the village, but that can be a hillside, that can be a building, or in our case, a tree, right? So put that all together, it's you know, it's a healthy order of magnitude and a half or something, right, in total cost. So this is game-changing economically, because this means with $10,000 of upfront financing, you could actually deploy this system in any village, right? This is a very manageable number. And if you share stuff like we're doing with the power of the backhaul, that reduces the cost, right? Because shared things cost a lot more than dedicated, a lot less than dedicated things. So combining the usage and the cost reduction, this is already profitable. And so this is the current profit numbers. And this includes the capital amortized and the operating expenses. So we're about, with the sharing, it makes about almost $500 a month at its current growth rate. And if it wasn't sharing, it had to have its own VSAT and its own power system, it would be quite a bit less, but still profitable. Now, I think this is a very interesting slide because this is not so profitable that a VC would invest in it, right? So when I say profitable, what I really mean is financially self-sustaining. That's the essential point here, right? This means that there is no ongoing philanthropy involved, right? Once it's in place, even with a loan, you can pay back the loan and you can operate the system forever, right? That's the model we want to get to. So we have one example point where this works. I think there's a second one in Oaxaca, although it's not as well studied. So this really says that at these prices, you can make this work in a way that should be sustainable and should be replicable. Now moving to the second problem, the carriers. So first, it's really worth knowing what carriers actually do in this context. So basically, we're building a little tiny telco. You can think of this as a community telco because it's doing all the things a telco does. Like, by the way, for example, we could do all the things that big telcos have to do, like we could wiretap, right? We're not wiretapping, but the power is there. It's kind of why I bring that up, because you have a lot of power if you're the telco provider, and it actually should be thought about for ethical reasons and others. But what carriers actually do in this space is interconnection. That's the classic phone term, which basically means connect one telco to another, or in general to all of them in the international space. So that's how you can call other countries. It's also how you call other carriers in the same country. So because we're not a real telco in Indonesia, we do not have interconnection, and therefore we had to use VoIP numbers, and we also couldn't get Indonesian numbers, which is point number 2, so we're using the Swedish numbers. These are both things that carriers can easily do and non-carriers have a hard time doing. Carriers also lobby to affect regulation. There is no counter lobby for communities. I think that's fixable, but it's worth pointing out that that's an important missing piece of this puzzle. And finally, the most obvious is carriers have spectrum, and they actually own the spectrum we're using. Now, in the case of Indonesia, we've actually talked to the Ministry of Telecom, and he knows that we're operating, and there's no damages because no one else is operating in the same area. And so as an experiment, he's fine with it. But if it became popular in Indonesia, there would actually have to be some discussion about how it should be regulated, how it should fit in, is it part of universal service, that kind of discussion, which I'll get to that in a second. So the options for spectrum are several. We're going to basically try them all. You can, of course, work with a carrier, and if that happens, that is the easiest answer, because they do not just the spectrum, they do the interconnection, they give you the numbers. So if we can do that, that's generally the best. We believe we'll be able to do that in the Philippines with Smart, which is one of the 2 big Philippine carriers. Philippines carriers are motivated because they have many islands that they cannot cover, right? So they actually are looking for new solutions, and that's why they're willing to try an experiment. We also may have an invitation to try this with Roshan in Afghanistan. Afghanistan also has many rural areas that are very hard to cover because of the mountains. They have a spectrum license also, so we can try it using their license. Another option that we are seeing actively now in Oaxaca is that the network there called Rhizomatica is their users are indigenous peoples of Mexico, and it turns out in Mexico, unlike the US, indigenous peoples have spectrum rights. It's actually, I think, still up for debate whether indigenous peoples in the US could get spectrum rights. It hasn't really been tested. But certainly many other countries have this as a potential option. There's also been discussions of setting aside 1 to 2 of the GSM channels for rural use. I think Finland is considering this. This is another way to do universal coverage. But this is more interesting because in some sense, the networks I'm talking about don't need more than 1 or 2 channels because their populations aren't big. And so it makes a certain amount of sense that if you put aside those channels, at least in rural areas, and a carrier came in later, they would have plenty of channels to operate what they want to do with no practical collision. So again, no actual damage from having someone in the space. And finally, there's been many discussions around universal service coverage, which originally started with landlines, but has in many places been spread to cellular networks and also even to broadband. And there's versions of this that could work well, such as there's been discussions of a version where if you don't use your spectrum in an area, then the government can give it to local operators instead. Right, so a use it or lose it kind of privilege. Or rural-only licenses, because again, no one buys rural spectrum today. They buy urban spectrum and they happen to get the rural spectrum with it as a side effect. Right, but that's a bad side effect for both sides. And there's one more, which is in some ways the most interesting, which is a bit more technical, but something the students have come up with that I really like, which we're tentatively calling GSM white spaces, to play on the idea of TV white spaces. The TV white spaces is a plan to reuse some of the TV spectrum without interfering with the TV channels, right? And the way you do that is you figure out which part of the spectrum is actually in use, which part is not. The part that's not is the white part, right? And you reuse with smartness the white part. So it turns out, I think we can make this work for GSM quite well. So in particular, the idea is make secondary carriers. So a secondary carrier is the second owner of spectrum, and they're not allowed to interfere with the primary owner, right? And so in particular, the onus is on the secondary to never interfere with the primary, right? The primary can prove that they're interfering, the secondary is in trouble. And it turns out there's a nice way to do this with GSM, which is the classic problem here is if I'm transmitting, I don't know if I'm interfering with other transmitters or not. Because I can hear them maybe, but I can't hear what my users hear. So when you're having a collision, it's at the user's end that you need to know, is there a problem or not? Well, it turns out GSM handsets have a very nice feature which we're going to abuse a little bit. So they have this feature which is you can ask a handset to tell you how much signal it's hearing on, say, 5 different channels. And the reason you want that is so that you can tell that handset to switch to another one of your base stations. Right? That's how you do handoff if you're going down the freeway, right? You have to switch base stations every couple miles or less, depending on the city, right? In that area, on that channel, I can switch channels. And base stations already have the ability to switch channels. In fact, what we would probably do is run 2 radios in the same base station, and then we can hand you off from one base station to the other, and in the process change the channel that you're using. Right? So I think we can make it completely transparent and very dynamic with no actual interference for the primary. So we're proving that this works right now. That should be done in a week or 2. And then we have to figure out how to have a spectrum policy discussion, which is not something I've done before. So if there's any spectrum experts, I would welcome advice. Let me wrap up. So in this community cellular model, we're really creating an island of coverage for the village with a few base stations that are interconnected, probably by Wi-Fi, leveraging existing handsets. Currently our backhaul is VSAT, but I actually think many options are coming. TV white spaces, the long distance Wi-Fi from an urban area, Loon, which is the Google balloons mentioned earlier today. And in fact, it's also worth pointing out this network is pretty useful even without backhaul, because you still get local SMS and calls within the village. So if you just wanted to call people in the village, it's kind of like a intranet, right? It works perfectly well as a standalone island. And finally, the really important thing we found is that you can lower the costs by getting help from the community, right? So sharing the VSAT with the school, sharing the microgrid power, volunteers to put up, antennas on trees, that kind of stuff makes a very practical difference that is not available to a carrier and also increases the buy-in of the community into the network. And there's a name for this that's called co-production, where a public good is co-produced by the community and the infrastructure provider. And Elinor Ostrom won the Nobel Prize for that in 2009. And really, it's the same effect that we're talking about. And finally, customized services and pricing. And we actually can do a lot more on the services side. So for example, things like local language voicemail, short-term job listings is really wide open. Because again, it's a general purpose server. We can run whatever software on it we want. We're actually building a framework for more general purpose services. So to wrap up, this is a very different way to provide coverage. And it's, I think, very promising. It's financially self-sustaining, so that I think it could be scaled quite well. And it's kind of unique in its community focus. The one in Oaxaca with indigenous folks from Mexico is quite different than the one in Indonesia, but they're both technically very similar. And so our next steps are kind of make this easier to install and manage, figure out how to enable financing once we get something that's a reasonable toolkit, and then finally figure out how to create more options for spectrum use. But I will say the pirate radio option is not that bad, right? It's either illegal or, as some call it, unlegal, meaning it's unclear in its legality, which is the case for some indigenous peoples. But there also has to be damages in practice for a practical infraction. In these areas, there are not damages because there is no use of spectrum, there is no carrier that's being hurt by this, right? And in fact, I would argue if they want to come in and serve the village instead, they would be welcome, right? But they won't. All right, I'll stop there and take questions.